Homework 4.4, Exponential and Logarithmic Equations, Video 5. Homework due Friday, May 29th at 11:59 p.m. This video and the following video are associated with homework questions 11 through 15 in Homework 4.4. In the first 4 videos in the series, we looked at ways to solve exponential equations. One way was to rewrite both sides using the same base and then canceling the bases. The other way was to isolate the exponential term and then use logarithms so that we could take advantage of the power rule. And of course we had that substitution example, which I thought was pretty neat. But for the remaining videos, we're going to discuss solving logarithmic equations. So equations that start with logarithms in them. Now, there are 2 types of equations that we're going to look at. The first type is when there are logs on one side of the equation. You can probably deduce that the other type will be logs on both sides, but we'll cross that bridge when we get there. And you may also notice that I've already set up a 4-step procedure for how to solve logarithmic equations, logs on one side. All 4 of those will not be filled in this video because the first step won't be necessary until the next example. So let's take a look at this one. Solve log base 2 of 4. Wait, let me try that again. Solve log base 2 of x plus 11 equals 4. Well, let's think about our goal. Our goal is to say x equals. Equation solving is a goal-oriented process. This is where we are. This is our goal. We need to fix what's preventing us from being there. The biggest obstacle right now is the fact that the x is located inside the argument of a logarithm. I don't want it there. So I need to find a way to get the x out of that logarithm's argument. Hey, didn't we rewrite logarithmic equations in exponential form once upon a time? We did. What would this logarithmic equation's exponential form be? Well, just remember what the answer to a logarithm does. The answer to a logarithm, in this case 4, is the power that turns the base into the argument. So 4 is the power that turns the base into the argument. So our second step in this list is rewrite in exponential form. What's the first step? You'll see. Be patient. We didn't need it on this example. We will in the next one. The advantage to rewrite in exponential form is it removes the x from the argument of the logarithm by completely getting rid of the logarithm. And now we can just finish solving this. That's step 3. Finish solving. Now, how easy or difficult this is depends upon the caliber of equation that you have. 2 to the 4th power is 16. This is a 1-step linear equation. Algebraically, linear means degree 1. Highest power is 1. And I shouldn't have to explain how to solve this. You should know that minus 11 on both sides is the move that gets the job done. 16 minus 11 is 5. We're good. But what's step 4? Well, I'll go ahead and tell you step 4 because it's technically necessary on every logarithmic equation, although in this one it will seem somewhat artificial. Logarithms have domain issues. You can't take logarithms of negative numbers. You can't take logarithms of 0. You can only take logarithms of positive numbers. There will be times where you will get a solution that will make the argument negative, and therefore the solution must be thrown away. So the 4th step is discard any solution that makes an argument non-positive. I was going to say negative, but negative is not the opposite of positive because 0 is neither positive nor negative. The opposite of positive is non-positive, which is synonymous with negative or 0. So in other words, we can't keep any solution that gives us a bad argument for the logarithm. So you don't really have to check your answer, you just got to inspect it. If I put the 5 here, will that make it negative or 0? More importantly is, will it keep it positive? Of course it will. 5 plus 11 is positive. It's specifically positive 16, but the thing I'm checking here is, when I put this solution into the argument, does it keep the argument positive? In this case, yes. Now, the implication here is that there will be some examples where the answer will be no, where we will put a solution or a tentative solution into the original equation, and it will cause the argument of a logarithm to be negative. Hence, we would throw it away. That would be an extraneous solution. In the next video, we'll take a look at a little more complicated example that not only will produce a solution that must be thrown away, but it will also explain why step number 1 is there, even though it is empty right now.